And we were very, very lucky. We can't tell you how lucky we are to have a very, very good friend of ours and also a legendary speaker. Jay, you've given talks all around the world. You've also given trainings at Black Hat. Did you train this year at Black Hat? Yep. And some people have actually asked, like, why do we have Black Hat? I mean, yeah, we have Black Hat speakers here. I mean, people, why are they speaking at 2 times? Because one thing we're very mindful is not everyone have the opportunity to go to Black Hat, and it's nice that you can come over here and see the content as well. So that's something that we're very mindful, because there's a huge significant cost to go to Black Hat. And it is our pleasure. It is our pleasure, and without much ado, this man needs no introduction, Jay Beale.
Thank you, thank you. I love that free applause you get before you even speak. It's kind of nice. Hi, my name's Jay Beale. Years ago, I created a hardening tool called SELinux. So you'll pardon the name of this talk. The focus of this talk is SELinux. I basically want to give you an awareness and understanding of SELinux that you could actually use, that you can go home with and start playing with things right now. If any of you have a laptop and want to crack it open, CentOS or Fedora or something that came with SELinux by default is really useful. If you don't, I totally understand. They are videoing this talk, and the slides are going to be up on InGuardian's website later on. So let's start. Just who's done anything with SELinux besides gone with set and force 0? Who's done anything with SELinux besides turn it off? Okay. Who's turned it off? Who's lying? Thank you. Okay, the liars are here. So what I'm going to do is, in my experience, most people with SELinux, they either never run into it, they never realize it's there because the configuration, the default config is so good that it's just on, it's helping them, and they don't realize it. Or alternatively, some set of people run into the first pitfall where something doesn't quite work the way they hoped, and they say, I'll just turn the whole damn thing off and I'll get back to this later. And later ends up being 2-3 years, sometimes when they were compromised and wishing they turned it back on. So I'll give a shout out to the SELinux people. They have worked very hard on making SELinux something that's much, much easier for all of us to use, and I think you're going to get that out of this talk. So what does SELinux basically do? It's you have discretionary access control. There's some theory in here. There's discretionary access control. That's the normal Unixy thingy where people set file permissions and files are inherently all readable by everybody unless you choose otherwise. Lots of us have had that experience of realizing that we can see and sometimes write to files in the system that don't belong to us, and sometimes that's what got us into hacker conferences. SELinux adds what's called mandatory access control. There are a bunch of things that do this, including AppArmor and Tomoyo and SMAC. SELinux is certainly the one that seems to provide the most comprehensive controls, but it also means it's got the steepest learning curve. So here's how I'm going to talk about how it works. We'll get into playing with it. I've got a couple videos that are inherently here to defeat the demo gods, and we'll hope that that works. Or I know that'll work because that's why we do it. So discretionary access control. Every single decision about access control that happens on a Linux system is first going to run into the normal Unix stuff that's been with us for 20 plus years. So Linux file permissions, file ACLs, root capabilities, all that stuff. If and only if the DAC permits that, only if the DAC permits that access, SELinux gets a shot. The first thing it does is it checks out its access vector cache, and the reason I'm telling you about that word is you see that a lot in the logs, AVC. And if the answer isn't in the AVC, it goes and looks at the policy, and that policy is stored on disk. It's really big. It takes a little while to look up, and that's why everything gets aggressively cached. So to make things really simple, SELinux's most popular policy is the targeted policy. It confines only some of the systems. So it confines the programs. A lot of the programs started on boot, generally everything listening to the network, and then some privileged programs like SetUID programs. So it's not trying to confine everything perfectly. SELinux can do that, but the targeted config doesn't try, and for really good reason. It gets really annoying. So basically, just like with the rest of hardening, this is a bang for your buck. Where's the highest risk, and how can I address that risk at the lowest cost? And I'm constantly trying to, and anybody who's designing a system like this, and when you're playing with a system like this, that's the trade-off you're trying to make. So the user processes by default aren't targeted. That means that all the users run in unconfined mode, and we're going to talk about that in a little bit. SELinux actually enables 3 different types of mandatory access control, type enforcement or TE, and then also RBAC and MLS. The targeted policy is all about type enforcement. You can do the other two, but that's not on by default, and I don't really recommend you get into it unless you're doing specific things like building kiosks or other systems that are going to have a lot of users on them that aren't very trusted or what have you. If you're most Linux servers, you don't even want to touch that for now. If you're ready to touch RBAC, if you're ready to touch roles and users on this, then you're done. Then skip past the rest of this talk on YouTube or wherever we're watching it, and just find your next talk. Okay, so SELinux. A few quick commands. You can use get enforce to find out whether the thing is on. You can use set enforce to turn enforcing on and off. And you can use SE status to see basically what mode you're in, and some other information like what policy's in place. If you're going to change things from enforcing to anything else, so people basically go with enforcing, permissive, disabled. Never, ever, 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 please, please, God forbid, please don't use disabled. Okay, you've got enforcing, that makes it work. You've got permissive, that lets it go and gather all the data that will be useful when you do want to use it later. It'll tell you all the things that it would have blocked if you'd let it, and having all those logs makes it a lot easier to profile your system, right? So, you know, at InGuardians we have work we do where we're like, okay, we want to make a really good outbound firewall for a client. What we need is a year of flow data. Do you have flow data? And they say, no. It's like you want to say, okay, come back to us in a year. You can generally be smarter than that, but in this kind of situation, what I want to do is say, instead of I turned it off, I have no data, I want to say, I told it not to block anything, and I kept all the logs for a year, or for 6 months, or 3 months, or however much time it takes you to get the data you need. And then the other variable here is targeted. So at its core, SELinux basically does this. It labels processes and files with security contexts. Okay, so it has a policy that says how those things are all allowed to interact. The parsing is default deny, but that would result in lots of denies, and so as a result, you end up with lots of types that are called unconfined or that are classified as unconfined, which means they can kind of do anything most of the time. So a label breaks down into a user, a role, a level, and a type. The only one that really gets used much is going to be that type. So you'll see, let's see, I'm not going to step out of the camera. They've reminded me, don't step out of the light. If I'm not being blinded, then something's wrong. I'm not going to be on camera. Okay, so this is going to be the best recording they've had all day. I've been promised if I just don't step out of the light. God, that sounds like some kind of, end of life thing. Okay, so go into the light. Go into the light. God, good. We need some humor in here. This gets a little dry, right? So you've got system, you've got object, and you've got a type on here, and you've got level and container and so on. And the only one you're going to pay attention to is this thing that ends in T. Now, this is the great thing. I really like the idea. I'm imagining that you're all drunk. Maybe 80% of you are drunk since this is DEF CON. Could you raise your hand if you're currently under the influence? Whoa. We might need to pass this around. Okay, so well, then my job's a little bit tougher. I was just going to say, okay, let's do this. Let's imagine that you're drunk, and so you can just barely focus on anything, and the thing I want you to focus on is anything in that line that ends in an underscore T. All you care about are underscore T's. Okay, so I have taken every single thing I was going to do on the command line and either made it part of the slide or made it into a video, so you're going to watch me flipping slides here. and we'll talk about it. So I can run, basically SELinux adds a capital Z to a bunch of commands. So instead of running ps-ef, you go ps-ef with a capital Z, and it tells you about all the SELinux stuff. And you're like, wait, I've been running on Red Hat for, so many years, and I never even knew this stuff was here. And that's mostly the goal of the people who are writing the policies. But you do that Z, and you start seeing, okay, you've got this program Avahi daemon. It's got its own type called Avahi T. You've got an SSH daemon. It's got a type called SSHD, SSHT. All of these types are basically how it gets labeled. Okay, SELinux has users. We're not going to talk about that because at the end of the day, basically, the way the users get mapped, this is a little bit harder to see on my copy of the slides. I'm going to turn toward the screen. Anybody who logs in by default is going to be unconfined. And then you've got the system user, which is system U. And that's it. There are like 8 more users that come with the policy. There are rules for them. And until you get some experience, don't touch those. Again, that's really, really good for the kiosks and for the public use systems. There are also roles, and in practice, there are only 2 roles that get used, the system role and the unconfined role. If you want to learn more about roles, look at the documentation. So we're all about types. Types and domains are the same thing. If you hear the word domain, just think of it as a type. If you hear the word type, think of that as a type. If you want to think of it as a domain, that'd be fine too. Whole idea of the domains is to basically say, we'll take all the programs on the system, we'll lock them each in their own little jails, we'll define what that jail is. When you use SELinux as opposed to normal Unix, what do you see? Well, if you're the Apache daemon, there are a bunch of files that are labeled on the system as ones that are ones that you're allowed to see, and the ones that anything else on the system that's not labeled for you to see, you can't look at. You can't read, you can't nothing. What does that mean? Why is that useful? Well, it means if an attacker compromises, like breaks in through your web server, or whatever, but they break in through your web server, they can read the web server's config files, they can look at the content that was there. If things are labeled as such, they could modify it, but sometimes you even set the permissions, sometimes you even set these rules so that somebody who takes over the web server can't actually modify the content. So just a quick count. It's all about types. There are 8 users, 14 roles, and 4,622 types. It's all about the types. By default, the user's processes run as this unconfined type. And unconfined is just an arbitrary name. There are other types that are unconfined. And we can run SEInfo and ask it, hey, tell me which domains are unconfined, and get a list. So we look at the first 5. We find there are 89 unconfined types there. So you can even take something and just add it to unconfined. We'll talk about that a little bit later. Now, with that said, we've said the users' processes all are unconfined, right? Except it turns out SELinux has this thing called transitions. And if you run a program that has an automatic transition, you go into a new type. You started out unconfined, and you end up in the password type. You end up in a type that's just for when you run the password program to change your own password. So the example here is basically, I'm running the password program, and then I've paused, and in another window I've looked and run PS and looked at my password program. And normally this would run with my user, except it's SetUID, so it runs with root's user. And normally it would run with my unconfined type, but now it's running with a password type. And that's how SELinux goes and confines SetUID programs and anything else. So you can basically say, listen, I got all these users, they're unconfined all the time, but whenever they touch this program, they're getting a lot of privilege. Maybe that lots of privilege is the ability to write to web server files or to write to somewhere they shouldn't normally be able to write to or whatever. Maybe it's the part where they run this program, they're able to talk to the network. And so you can then say, hey, I'm going to make it so that I'm sticking you in a box. Normally, a user, you can do anything the hell you want, but when you run this program, I know what that program does. I know what files or what have you it needs access to. I'll confine it, and you're confined just for that. So that type transition, this is the big control around SetUID programs. If you've been in my class, you know, like one of the things we talk about is SetUID is the biggest internal privilege escalation risk. An attacker, you find some SetUID program that's got a vulnerability in it, you use the vulnerability, and this program now, instead of just, letting you change your password, lets you have a shell on the system running as root and thus do anything the hell you want. unless you're in an SELinux situation or AppArmor or one of the other mandatory access controls where now you're getting stuck and confined. Okay, so y'all having fun? This stuff can be dry, but it can also be very useful. I see a few of you starting to take a swig out of a little bottle. That does help, I promise. But okay. Let's see. So SELinux, the type transitions you basically spell out. We're gonna look at what happens when you run password. The password has 3 types that it deals with. I want to step out of the light and point to the screen, and I'm not going to do it. I'm not going to do it. This is going to be a great recording. I mean, you might want to mute it if this is boring, but at least I'm going to be the one who stayed in the light. I'm so happy about it. Okay, so I'm trying to see, but I've been blinded by the light. Where's our song? Blinded by the light. Okay, don't drink, Jay. You sing and it's bad. Okay, so password T. So password lets you edit the shadow file. Shadow T is the shadow file, and then password exec T is what you label the password program as. So in order for you to have this transition thing happen, if you wanted to write your own transition, you do it like this. So unconfined T, what your user was running as already, has to be able to run the password program. So it has to have execute on the password exec T type. And unconfined T has to be allowed to transition into password T, that thing we're going to be when we can write to the password file. And password exec T has to be defined as an entry point, as a way in to password T. And so what you end up with is these are your rules, and those rules basically do what that diagram just did. And they add one more thing, which is this first line. So those last 3 were all the allows. And then that first line basically specifies that it has to happen whether people like it or not. So specifies the transition and makes it automatic. It's not just something you can request, it's something that happens whether you like it or not. So there are a lot of these transitions. There are more than 12,000 of them in the Red Hat 7 policy. So yeah, this is pretty integral to the way the system works. So I'm going to go into an example now, and what I want to show you how to do is the main thing you're going to find yourself doing on SELinux systems. So there are basically 3 things. The one is that something's going to go wrong. You're going to move a file to another place. You're going to need your you're going to move the web server space where it keeps all the files. You're going to need to know what you do so that the web server can now see this other directory. Okay, so that's the one. The next one is you're going to flip Booleans because you're going to think of something the system needs to do, and the folks who maintain the policies have already thought of that, and they've created a nice little on-off switch, and that's your basically second most common thing. And then the third most common, which is pretty rare, is when you actually add a new program that's nothing like the others, and you have to add new types. Okay, so let's look at this first, just starting with bind. So we've got bind. And we look at just the files for named for the bind DNS server. What we find is, remember, we don't look at the U, we don't look at the R, just razor focus on the T's. And I've tried to make it simple by there are only 3 types here, so I've taken those 3 types and put them in red. And I even got it right. So the named configuration file is of type named-conft, okay? And you've got named-cache T. That's going to be for anything that is going to be primarily for the things that named is changing. So that'll be where it's keeping its file caching data, and then you have named zone T, which in general is stuff that you don't change. Now, if you need bind to be able to maintain its own zone files, there's a Boolean for that, and we'll get to that later. So let's look at what bind D runs as. Or what named runs as. Named runs as named T. So named is what named runs as. That's basically the name of bind or named's jail. Its domain is called named. And the binary itself is labeled as named exec T, and that differentiates between hey, who's allowed to run named exec T? Once they run it, the system transitions. We have a transition into named T. So the named T type can read the configuration file, can write to files. Okay, so you can, if you want to, this is one of the most useful tools in SELinux, honestly, if you want to understand how the policy's working, is SE search. You fire up SE search, you do a minus minus allow or a minus capital A, and say what source domain are you looking for and what target domain are you looking for, and you'll see the rules that basically say named DT is allowed to do this and named DT is allowed to do that. So what I want to do is do an example real quick, and this is where I'm going to switch over to a video. The bottom of the slide says let's change the label on named.conf from what it is right now, from the named.conf type, over to the same one that's used for root's home directory. So I'm going to switch over and do our first video. Let's do full screen on that. So I change it. And I'm going to try to start named D. And I'm going to get an error. Named D won't start for me. And I'll just change it back in this case. Now we're going to deal with this same problem where we actually change the configuration. So I change it back, and I can start it now. And it started just fine. So this is the slide where we do that, and we changed it back, and we're able to start named D. So I'm going to talk to you now about basically how we create a new module. So instead of just changing it back, we can actually change the configuration of the system. That chacon is all, the reason I also showed you that is that chacon is like chmod and chgroup and chown. It's basically change file context. If you want to change a file's context, at least until the next reboot, you do it that way. I'll show you how to make it permanent later on. So the SELinux policy is made up of modules. There are 393 of them to start. On Red Hat 7, you end up with more over time. The modules are just the way they've broken up the policy. They could make the policies one big monolithic thing, and to be honest, it gets compiled into one big monolithic thing. But we're going to create a new module, we'll activate it, we'll deactivate it. By having it modular, we're able to turn the stuff off. So let's look and see how we can make a new module. So we saw this log message about how named had a problem. And so we can just basically look at the audit log where the SELinux errors are getting written. It's one of the places. And we can pipe it into a program. This is going to be one of your favorite programs if you play with SELinux, called audit to allow. And it basically says, I can turn entries in the audit log into allow rules that you can then load. You don't have to even learn the allow. You don't even have to learn the rule language. It's not that complicated to learn it, but you don't have to learn it for most anything. So what we're going to do is we're going to run audit to allow to create a new module called something like named admin home. That'll be I'll show you the rule that generates. We'll insert that module into our running policy, and then we'll have one more, and then stuff's going to work. So let's look at that video. All SELinux work should have a driving bass beat behind it like this. Okay, so here we go. We've got roots. Home directory is admin home T, so we're going to change etcnamed.conf to have that same type. Now we're going to try to start named. It's going to fail. We're going to look for log messages in audit.log. And we're not even going to look at them in this case. We're just going to pipe them straight to audit to allow. And we're going to tell audit to allow that we'd like it to make a new module called named can read admin home T. You could just call this Joe if you wanted to. And it says, hey, here's how you put this in. So we're going to look at it. It creates two files, basically. There's a TE file, there's a PP file. The TE file basically is I'm going to pause right here. The TE file has two basic important lines. So it has a bunch of like, hey, you need to make sure these types are defined. And as long as they're defined, I'm skipping the other lines. So I end up with two new rules. And the second of these rules is the one that we were aiming for. Audit to allow caught another issue too. But this second rule says allow named T to read files that are labeled with admin home T. Okay, cool. It's just one simple thing. So, okay, I've highlighted it. So I'm going to insert that module, SE module. The same thing it asked me to do. It's that simple. We can do it while intoxicated. I don't recommend adminning systems while intoxicated, but it does sometimes make it fun. You have to wait while that module gets while the whole darn policy file gets recompiled. So it takes about 5-6 seconds on this laptop that's got that has an SSD. So I try to start named and it still won't start. Something else has gone wrong. So I'm just going to go and say, oh, screw it. Let's cat that autolog again. Let's create a new file. Create a second module. Insert that module. Wait our obligatory 5 seconds, maybe 6. Come on. Okay, it's done. Man, computers have gotten so fast, we don't wait for anything that long anymore unless we're on a Raspberry Pi or any other IoT system on a chip, 8 megahertz thing that's still faster than my first computer. So we can run that. Now we can start named successfully. Everything's great. So that's honestly the thing you end up doing the most in SELinux. There are a few other things we can do though. So we used Chicon before to relabel a directory so that named could read it. If we want to make that permanent, what we end up doing is using SEManage file context. I'm gonna -a for basically add a type, named zone type, to all of these to this directory, and then to anything under it. You'll notice this is regular expressions. If you're a Unix admin or a Windows admin for that matter, or heck, if you're at this conference and you don't know regular expressions yet, find 5 or 10 pages from a good book, read that, and you will gain like another what's it called? Little loop on your karate belt. A stripe. There you go. A stripe on your karate belt. It's pretty worth it. Okay, I told you that you've got these booleans, and if you run SEManage boolean -l, you'll see all the booleans in the system. There are a whole bunch of them. If you look at named, it's going to tell you there are 2 different booleans. If you were to make it so that your named server is going to start, like, say, signing your zones for DNSSEC, or otherwise is going to need to write to the zone files, maybe it's a slave DNS server, then what you can end up doing is basically just changing one boolean, that named write master zones. And that's something that the people writing SELinux policies have done, that let their policies be as tight as possible while not breaking things if you're in a different configuration. So the way I think about it, whenever you're hardening a system, is you're customizing that system from the general purpose that the operating system was shipped as to now being really specific to what you want. Sometimes that's stripping out code. Sometimes that's just flipping booleans in an SELinux config file. One way or another, that's what you're doing. And so I love that SELinux has these kind of nice on-off switches. And you can use getCbool to see what the status is of one. You can use setCbool to change it. If you change it and things are working, you set it persistently with another flag, with that -p flag. Here's one more thing that I haven't mentioned in terms of what you'd be doing when you're creating new files. If you move the port on something, SELinux will usually break. Will usually break what you're doing, and that's good. And that's also really, really impressive. As an attacker by day, that's really what I get to do most of all. I only get to play with this stuff kind of as a very, very, very tiny part of my work. As an attacker by day, what I find is, you compromise a computer. That usually means you compromise a program. So you're in the running execution of that program, and whatever the rules are on that program, those are the ones that are confining you. You're hoping to just get a root program or a program running a system or what have you, and be able to do whatever you want. But when you have a mandatory access control layer in, if that mandatory access control layer is like this and says, you can bind to port 53 and to no other port, well, that's really a pain in the ass. As an attacker, what I want to be able to do is I want to be able to create arbitrary connections out. I want to be able to allow arbitrary connections in and bind other ports. So SELinux doesn't do that, and this is one thing I like about it over AppArmor, and that is that you can basically say, hey, this is port 53 was your port. Okay, that's the only port you can listen on, and you can actually specify all the different behaviors in terms of what ports it's allowed to listen on and talk to. So you can go and change it. If you add 54 in, you basically run one command, SEManage, my port definition. I'm going to take the DNS port T definition and say, that's not just port 53 now it's 54 too. Okay, just a couple more slides. So SEManage permissive. I can set. So I told you never to turn it off. Always put SELinux in permissive mode, so it should either be in permissive or enforcing. I'm going to tell you next that what I really recommend you do is you always leave SELinux in enforcing mode, but if it's getting to be a pain in your butt and you're thinking about turning it off or turning it into permissive mode, then go and take the one program that's getting in your way, the one program that you're trying to get work that isn't working right now, and basically say, okay, its type, in this case the name DT type, if you can't figure out how to make things work right now and you want to come back to this later, go and take the entire name D type and just say that's in permissive mode but the rest isn't. Now I know some of the purists right now are like, oh my God, he's turning things off. He's the security guy. He's not supposed to turn things off. He's the blue team. What the hell? And what I'm going to say is this: I've spent enough time where what I've learned is if the configuration is too tight or the tools are too hard to use, people will often go all or nothing. So they'll go from it's going to be super, super tight. Wait, that didn't work. Okay, we're throwing it entirely out. And sometimes that throw it entirely out isn't really their decision. It's their boss who says, listen, you can't make this work. Screw it. We're turning it off. We'll look at it again in a year. So what I like to do is then say, okay, let's find the damn middle ground. If you have to, take one program, turn it into permissive, and spend your time profiling that and figuring out when you're able to get it back into that fully locked down mode. That also means that even while you're stuck trying to figure out how to make that thing work, or you're in a delay loop, or you have to wait a year to build trust again, cool, for that year you have the rest of SELinux. And I think that's a really good idea. It may sound like I'm trying to sell SELinux here, but it's free and it's on all your systems and you can play with it really easily. So I just think it's a really great technology, but most of us don't ever touch it just for lack of this kind of 1 hour or 45 minutes of introduction. So yeah, that's mostly it. I've got a quick SELinux is logging to the audit log the way you saw. And if audit D isn't running, then it doesn't log to the audit log yet. It just logs to varlog messages. But there's also a program on Red Hat, on my Red Hat system that's now shipping by default, which is SE troubleshoot D. And it'll tell you how to get more data, and it'll give you, with SE alert, it'll give you kind of more, it'll give you an explanation that's a little bit easier to read, and I like that a lot. Lastly, I just want to mention there's some SELinux alternatives. If what you saw here was holy bejesus, I never want to play with this. This is not going to work in my environment. It's too complicated. Maybe I'm one of the new funky DevOps kids, and we're not going to do it that. I don't know, whatever. But it's whatever your reason is. There's some other alternatives. There are three big ones. One is AppArmor, which is what ships on Ubuntu by default and SUSE Linux. You've got Tomoyo and SMAC, and SMAC I know actually a bunch of us are running and we don't know it. It's on the Philips smart TVs. The only one of these three that I've played with a lot is AppArmor, and I think AppArmor is really, really neat. So SELinux can give you better assurance. It can give you a heck of a lot more control. It's a little bit, but the difference between SELinux and AppArmor is almost like the difference between driving a stick-shift car and an automatic. Some of us want the control of sticks so that every single time we're like going from stopping to starting, we're exactly engaging, we're exactly deciding when the clutch engages and when we get that nice, powerful, push forward, right? But some of us just want the car to freaking go. AppArmor's not quite just go, but it is really, really fast and easy to write a profile with, and I enjoy that a lot. So I'll make my push for AppArmor. If you thought SELinux was too much, I could teach you. I know this from teaching my classes. I could teach you how to sit down and confine a root shell to something that can do, say, 3 things in under 10 minutes. So that should speak to the ease of creating AppArmor profiles. The downside is that AppArmor basically confines root capabilities and file access. You're not going to get the same kind of, among other things, you're not going to get the same kind of program can't talk to the network, or sorry, more to the point, program can only talk to these ports in these ways. So that's the deal. Anyway, I hope this was fun. It's 1:43. I think this is one of the first talks I've ever finished early. We're 7 minutes early, so what would you like? Would you like to ask me questions? Should I do some kind of dance on the stage that hopefully won't be caught on camera? Dance. Wait, there's a question on SELinux before we dance. Maybe I can stall. Okay. If the boss says that if you turn SELinux on, you're fired, you stand your ground. You are going to serve your organization best by being an example. Yeah, the guy who got fired. No. No. So my thought is, if the boss says you're going to get fired, like, have a conversation, realize you're in a negotiation. So I have a talk tomorrow on phishing that's a lot more human than the SELinux stuff. It's a lot more talking actually about communication and negotiation and collaborating with your client or with the other people at work and trying to have the situations where you think that your two choices are either to piss off the other party, whether that's your client or your coworker or your boss, or to instead, give in and basically create a solution that's bad. Go talk. What's that? Plan 6 months ahead? I have no idea what you're saying, but I'm gonna take the next question. What was that? I do a lot of pen testing for the day job.
Have you ever encountered in the wild somebody configure SELinux on their system and just totally fuck it up?
Have I ever configured anybody in pen testing, configure SELinux on the system and totally fuck it up? Does fuck it up mean make the system not work or make my attacks work more easily? I don't think so. No, I mean, honestly, if I'm in a pen test and I end up compromising an SELinux system, my goal is to be a user where I've got that unconfined. If I end up in a confined process, I'm pretty screwed, and it's time to find another. It's time to find another way in, another machine.
Well, I ask because there's like this legend that it's impossible for anybody to configure unless they're superhuman.
There's a legend that it's impossible to configure SELinux unless they're superhuman. So I will say that you can. I've shown you how to do some configuration here, and a lot of that relies on the types that are already on the system. You can go and create your own types, and that's what you'd have to do for a whole brand new program. And that is a bit more of a pain in the butt, especially if you don't know what the program does to start. The nice thing is that the people who've been creating SELinux profiles for all of us have been doing it for like 10 odd years. And so the profiles have gotten really good, and so we tend to only have to tweak them. If you do have to create one, it is not impossible. You don't have to be a god, but you do have to have some time on your hands. And that's what I'll say. There are also some really, really good books out there. I'll also tell you that a lot more of you are running SELinux than realize it. The most recent version or two of Android is got SELinux on it, and it's enforcing. So there was another question back right. I'm going to ask you to repeat the question. It basically was Linux containers where you've got a binary, it's running in a container, and you've got stuff bind mounted in.
Like your file system's bind mounted, it may be running a binary that also has an SELinux profile on the host.
Yeah, we've got a pretty complicated situation. As soon as you're talking about a program that's in a container that has a profile on the outer host that is trying to, and the outer host profile isn't so bad because the program in the container is almost always trying to. Wait, is that waving hand back there an answer to the question? Oh, we have a really good answer. We'll get your butt up here. Oh, that's a really good question, but we're not going to do that right now. So the container thing. So the container question. Yeah, as soon as you're in a container, you end up in a different type anyway. And usually the containers basically say, I've got all the things that are in the container. They're all going to be labeled with the type that the programs that are contained can read. And the bind-mounted stuff ends up being a whole different thing. So no, I don't have a good answer, but I will get you a good answer. And God, if it's really simple and you're watching this and you're smacking your head and saying, Beale, what the hell? I apologize. I owe you a drink if you can come up with an answer that fast. I'll make sure that next time I get this question, I'm better prepared. Thank you. Okay, we got 2 minutes left. We talked about the other question back there was, what if you want to use Tomoyo and you don't speak Japanese yet? Well, obviously as hackers, I mean, I've watched enough anime to know that as hackers, we all speak Japanese, like out of the womb. I mean, at least you do if you're cool, right? I mean, you speak Japanese, right? He does. He does. He won't admit it. Okay. Any other questions? Cool. Cool. Oh, dance. Does anybody want to come up here and dance with me? I'm stepping out of the light. I'm hoping that camera can't be moved. Uh-oh. No, that camera's panning. Okay, if you want to see me dance, then you have to come to whatever the biggest parties are that where Keith Myers is playing. If Keith Myers is playing there and I'm dancing, I'll be dancing there. So I don't know if there's not really great music for this. Let's see what I can do. That's my drunken frat boy dance.